Hey, welcome back to your favorite calculus class. We're going to take a look at substitution of definite integrals today. And so we're going to just apply our fundamental theorem of calculus, which says when I find my antiderivative, the integral there, we got a capital F of x. We're going from a to b, and we're going to plug in that b, subtract, then we're going to plug in that a. All right? So we're going to go ahead and do that on this one. You notice we have an integral, but we have a radical here, so we're thinking to ourselves, well, u is probably going to be the radicand. So let's go ahead and try that first. Let's let u be the 9 plus x squared. So our du dx equals 0 plus 2x. Take the dx to the other side. So what would this become? We've got the integral from 0 to 4 of x squared to 9 plus x squared dx. Well, our u is right there, so we're going to have the square root of u, and then du is 2x dx. Well, we have an x dx, we don't have a 2x dx, so we can give it a constant. Constants are not an issue as long as we offset them. 2 times a half, of course, is 1. So we've got the integral of 1/2, and then here's our 2x dx, there's our du, and then we've got the square root of u. And we're going from 0 to 4. Now remember, this is x being 0 to x being 4. So after we take our integral, right, we got u to the 1/2, so that's going to be u to the 1/2 plus 1, that's 3/2, all over 3/2, in other words, times the reciprocal, times 2/3. We're going from x being 0 to 4. So notice my 2's cancel. So I got 1/3 u. So let's change back to x's here. U is 9 plus x squared to the 3/2 from x being 0 to 4. And now let's throw in our 4. And then throw our 0 in. So we got 1/3. 9 plus 16, we got 25. 3/2 minus 1/3. 9 plus 0 is just a 9. So we've got 1/3. This is like 25 to the half to the 1/3, right? That's 3/2. In other words, the square root of 25 to the 1/3. Same thing with this one. So 5 to the 1/3. Square root of 9 is 3 to the 1/3. So we've got 25 thirds minus 3 times 3 times 2, 27 thirds. So it looks like this ends up being 98 thirds. Here we've just got it in terms of theta. But if I've got some sort of rational function here, I've got sine theta in the numerator, I've got 3 plus 2 cosine theta, quantity squared on the denominator. Hopefully you're thinking, well, who am I going to let u be? Most of the time is probably your denominator, so we're going to try letting u be that 3 plus 2 cosine of theta, and let's see if that'll work for us. So du d theta would be derivative constant is 0, derivative 2 cosine theta is 2, derivative cosine is negative sine theta. Now let's take our d theta to the other side, so we got negative 2 sine theta d theta. And so what would this become? Well, we have sine theta on the top. We got 3 plus 2 cosine theta squared d theta on the bottom, from theta being 0 to pi halves. Now we need for du, we need negative 2 sine theta. So I got to give it a negative 2, which means I got to offset it out front. But there's our du right there. Oops, let me do that a little better. There's our du. And here's our u. So I got 1 over u squared du with that negative 1/2 in front. 1 over u squared du from theta being 0 to pi halves. So I got u to the negative 2. So let's go ahead and run that. That'd be u to the negative 2 plus 1, negative 1 over that negative 1 from theta being 0 to pi halves. Negative times a negative is a positive 1/2. And then u to the negative 1, that'll go down u to the 1. And this is from theta being 0 to pi halves. Let's plug the u back in. Let's throw our pi halves in. So we got 1 plus 2, 3 plus 2 cosine of pi halves minus and then cosine of pi halves is 0. Cosine of 0 is 1. So we got 1/6 minus, let's see, it's equal to 5 1/10. So we've got 5 over 30 minus 3 over 30. So we got 2 over 30 or 1/15. Guys, this next one's a good u try problem. You want to pause that video there. Let's go ahead and let my u be that radicand again. And go from there. I'm going to pause it. Write it out. Alright, I've written this out with our u and our du substitution, which you notice is secant squared d theta. And it ends up giving us the integral of u to the 1/2. And I'll go ahead and run that integral. I get to this point where I'm plugging in pi, then I'm plugging in minus, subtracting, plugging in pi 4. So we got tangent of pi, got sine of pi over cosine of pi, which are sine of pi is 0. That's going to clear that out. Sine of pi 4 is root 2 over 2 over cosine of pi 4 is root 2 over 2. So I got 1 right there. So the 0 to the 3 halves times 0, that's just going to give me 0. 1 to the 3 halves is 1, so I just got negative 2/3 on this. Now on this one here, you're probably thinking I should let u be 4 minus x squared. So my du would be negative 2x dx. Now we could introduce a negative 2, but the problem is we cannot introduce an x. Right? That's impossible to do. We can't do that with our properties of integrals. So we're going to say that's not going to work for us. We're going to have to go ahead and look at our cheat sheet and go with something else. So I look at my cheat sheet, and if you notice on my cheat sheet I have one that looks like this down kind of near the bottom, and it's the integral of 1 over the square root of a squared, a being a number, minus u squared du is the arc sine of u over a plus a constant. So hopefully you're looking at that and you notice my a is going to be 2, right? It's going to be 2 squared. So my a will be 2, and my u is just the x. There's my u. So if u is x, I don't need u substitution. If it was something besides x, like instead of square root of 4 minus x squared, like maybe it was 4 minus 16x squared, well then my u is 4x, and I got to account for that, right, with u substitution. But here I don't have to worry about that. So let's go ahead and rewrite that. 0 to 1. Let's recognize, oops, this is 1 over 2 squared minus x squared. Again, there's our a, there's our u. And so I can just apply the integral. So it's the arc sine of u, which is x, over a, which is 2. So we got the arc sine of x over 2 from 0 to 1. So we got the arc sine of 1 over 2 minus the arc sine of 0 over 2. So the arc sine of a half, and maybe you need to go to the side to remind yourself, if the arc sine of something equals, we'll call it theta, then the sine of theta equals a half, right? And I'm looking between negative pi 6 and pi 6 for this. That would be pi 6. Sine of pi 6 would give me a half. So the arc sine of a half is pi 6 minus, and then I do arc sine of 0. I could do the same process for that. I get 0. So we end up with pi 6 minus 0. Now this one we got 1 over x ln of x. You're trying to look for a u here. Again, we don't have any straightforward integral formulas here. So I'm looking for a u whose derivative will help me out, right? So I would be looking at that natural log. If I was doing that, I'm like, hey, if I let u be the natural log, then du dx would be 1 over x. In other words, du would be 1 over x dx, right? And notice I have a 1 over x dx right there. Circle that very good. 1 over x dx. There we go. That's my du. And ln of x is my u. And so what I end up with is 1 over ln of x, 1 over u. And then I replace the yellow highlight with my du. And I'm going from x being e to e squared. Well, now I can look on my... well, actually, I should know that the integral, I should have that one memorized. The integral of 1 over u is the natural log of u from x being e to e squared. Well, let's go ahead and replace our u. So we've got the natural log of the natural log of x from e to e squared. So we've got the natural log of ln of e squared minus the natural log of the absolute value of the ln of e. Well, the ln of e squared, remember ln and e undo each other, right? Here's my natural log of x, and here's my e to the x. They're inverses. In other words, they're reflective about the line y equals e. So they undo each other. ln of e squared is just the 2, right? ln of e to the 2 is 2. I still got this ln on the outside. All right, so I'm applying the natural log on the absolute value of 2. Of course, the absolute value of 2 is just 2. So I just got the ln of 2 for this. And then over here I got ln of e to the 1 is 1. So we got the natural log. Of course, the absolute value of 1 is 1. And I've got the natural log of 1 is 0, which is that point right there on the graph, right? So ln of 2, which is some positive value, minus the natural log of 1, which is 0. So we just end up with the natural log of 2. Well, thanks so much for watching, taking notes on section 5.6. See you next time.